Today we are looking at compositions of functions, and this is a straight up review from Algebra 2, so hopefully it will go pretty smoothly for you. And so a composition of functions, another method besides the operations that we did last time. Another method of combining functions is called composition. So if you've got f of x and g of x, then the composite function is f of g of x. So that is defined as f of g of x. And it kind of looks like fog, but it's not an O. It's like a little tiny open circle. But you have to be careful not to assume that this little tiny open circle is like multiplication. Multiplication's a dot. This is a little tiny open circle. So really, the other way to see this, maybe you saw it this way, maybe you didn't, but another notation for this would be f of g, I can write it correctly, of x, okay? And I like this one better because this kind of shows you, for f of x, you were replacing x with g of x. That's what's happening. I mean, you say both of these f of g of x, you could write it either way, whatever works for you, okay? So I'll kind of do it both ways down here. Let's look at number 1. So they give me f of x and g of x over here. So I have f of g of x, which is f of g of x, right? So that means I'm taking g of x and putting it into f of x. So take this, everywhere I see an x, I replace it with g of x. So that means that this becomes x squared minus 4 plus 7. So then when I combine all of that, f of g of x equals x squared plus 3. And on your final step, whether you write it this way or this way, I don't care either way. I just want you to know it's the same thing. Okay, so g of f of x. So g of f of x, okay, if just saying it isn't going to get it in the right order in your brain, then write it out. G of f of x. So you're taking f of x, and everywhere you see an x and g, you substitute it. So this becomes x plus 7 squared. Anytime you substitute anything with more than one term, you put it in parentheses. X plus 7 squared and then minus 4. Okay? So this x plus 7 squared, here's what it is not. It is not, here I'll write it right here, x plus 7 squared is not x squared plus 49. Okay? You cannot afford to make a mistake like that. When you square a binomial, you get a trinomial, okay? It's a perfect square, so there is a rule for that on that factoring flow chart. You kind of know what it is. If not, you need to, be able to go through it somehow. But your rule for that is you square the first term, that's x squared. Then you double this and multiply it by x. So this is going to be plus 14x. And then you square this, which is 49. Okay? So square it, 2 times these two things multiplied together, and then square it. That's how you do the perfect square, and then we do a minus 4 back here. So g of f of x is equal to x squared plus 14x plus 45. Okay. All right, so let's look at number 2. Got f of g of x. So f of g of x, meaning I take g and substitute it into f. So this is going to become 3 minus x over x plus 1. Okay? And here's one thing I want you to notice in my work, because this is important. And I talked to Mr. Ackerman the other day about a student that they were getting all these points taken off on their test because they had a bunch of stuff, but they didn't have equal signs, and you weren't continuing that. So you see I have this equals this, equals this, equals this, and like you have to continue that and not just have random stuff written everywhere. The format of your answer, the process, way more important than just the final answer. Okay, so here's this equals, when I combine those, that's a whole number and a fraction, so I have to have a common denominator to add them together. My common denominator will be x plus 1, which means I have to multiply this by x plus 1 over x plus 1. So we get 3 times x plus 1 over x plus 1 minus x over x plus 1. All right? So then when I distribute this. This is going to be 3x plus 3, so I'll just rewrite that, 3x plus 3. And then that means that I get f of g of x equals, so 3x plus 3 minus x is going to be 2x plus 3 over x plus 1. Oh, well maybe I could have reduced this. Think I should cancel these x's out here? I would only do that if I wanted to be wrong. Because if you have addition or subtraction here and you've got two terms, you cannot just cancel stuff out. You would have to factor out a GCF. You cannot afford to make those mistakes anymore either if you're making them. All right, so then g of f of x, so I take f and substitute it into g. So this is going to give me 3 minus x over 3 minus x plus 1. So that gives me 3 minus x over 2, no, not 2, my goodness, over 4 minus x. Oh, well maybe here. Can I cancel these x's out here and have 3/4? No, you cannot. You would have to factor out a GCF. This is equal to g of f of x. Oh, well, there's not extra equal sign, that's okay. All right. Here we have f of g of x. So I'm going to take g of x and substitute it in everywhere I see an f of x. I'm sorry, everywhere I see an x in here. So this is equal to, so I get 9 minus 2 times 4x plus 1 cubed. So I need to take this and cube it. So I'm going to move over here so it doesn't get all mixed up with the rest of my work. So 4x plus 1 cubed is equal to 4x plus 1, well, let's look at it this way, 4x plus 1 squared times 4x plus 1. So do I just get to square this and square this? No, it's a perfect square again. So to square this, I square the first one, that's going to give me 16x squared. I multiply these two together and double it, so that'll give me plus 8x, and then plus 1. So I'm going to take this and multiply it by 4x plus 1. Okay. So then see if you can finish that part off. Finish, pause it, and then multiply these two together, and then let's see if we agree. Okay, so if I multiply these, I would start with my distribution here. So I'm going to get 4x times 16x squared. So it's going to give me 64x cubed. I'm going to take 4x times 8x. That's going to give me 32x squared plus 4x. And then 1 times all of this, so that'll give me 16x squared plus 8x plus 1. All right, so I'm going to clean all that up. I only have 1 cube, so that's 64x cubed. So I used that. When I have a bunch I'm combining, I like to mark them out so I make sure I used them and didn't forget anything. So I got 32x squared and 16x squared, so that's 48x squared. Then I have 4x and 8x, so that's 12x, and then plus 1. So that's what I'm substituting in for this cubed. So I have 9 minus 2 times, and that's 64x cubed plus 48x squared plus 12x plus 1. I've got this 9. I'm going to distribute this. So this is negative 128x cubed minus 96x squared minus 24x minus 2. So then I have to combine this 9 and this 2. So I'll have f of g of x equals negative 128x cubed minus 96x squared minus 24x, and then 9 and a negative 2 is plus 7. There's my answer. All right, so then let's do g of f of x. So I'm going to substitute f of x into here. So this is going to give me 4 times 9 minus 2x cubed plus 1. That gives me 36 minus 8x cubed plus 1. So g of f of x equals negative 8x cubed plus 37. Alrighty. So we are going to do the next few, even though I feel like you understand the concept, but there's some things that happen in here that I think would be good to talk about. So we're doing f of g of x. So I'm going to take g of x and substitute it into f of x, right? So I just substitute it in, and that means that this gives me the square root of x squared plus 5. Okay, and then you always want to simplify if you can. I can't simplify this. Yes, I know I can take the square root of x squared, but just like why I can't cancel in the rest, there's two terms here. This as a whole thing is not a perfect square, and I can't just take the square root of the first part if there's addition or subtraction there. That means then that f of g of x equals the square root of x squared plus 5, and that's it. Now g of f of x, that means that this is going to give me the square root of x plus 5 squared. Well, anytime you square a square root, you just end up with what's underneath it. So g of f of x is equal to x plus 5. And that's it. Okay, so that square root looked like it should have been complicated. Really fairly simple there. So you try number 5. See if you can get through these square roots or cube roots without making anything up. And then come back and see if we agree. All right, so I want f of g of x. So this is going to give me the cube root of x plus 4 cubed minus 1. So just like if I square a square root, I get what's underneath. If I cube a cube root, then I get what's underneath. And I get x plus 4 minus 1. So f of g of x equals x plus 3. All right, so then I do g of f of x. So this is going to be the cube root of, for x I put in x cubed minus 1 plus 4. So that's going to give me the cube root of x cubed plus 3. Okay, so I should be able to factor sum and difference of cubes, but this is not a sum of cubes because this is not a perfect cube. I can't just take the cube root of this first part, so that's all I can do, and this is g of f of x. So that is us finding the new function. The next thing we are going to do is evaluate the function. Okay, we actually evaluate it, substituting stuff in. So you can do this one of two ways. I mean, you can kind of put it together like we were before, or you can find them separately. It doesn't really matter, right? But I would suggest actually rewriting this just because I feel like it makes a little bit more sense. F of g of 3. So that you know what do you have to find first? Well, I have to find g of 3 first. So I'm going to find g of 3. That's equal to 3 plus 1, which is 4. So now I have g of 3. That's what this is. Since this is g of 3, f of g of 3 is f of 4. So f of 4 is the absolute value of negative 2 times 4. And that is equal to a positive 8. So that is f of g of 3. Okay. So you try B, and then come back and look. So this is this is equal to g of f of negative 5. So the first thing I need is f of negative 5. So that's going to give me the absolute value of negative 2 times negative 5, which is going to give me 10. So f of negative 5 is 10. And so that means really now I need g of 10. And that's equal to 10 plus 1, which is equal to 11. So g of f of negative 5 is 11. Let's try example 7, or you could try it 100% on your own. That's fine, and then see if we agree. So this is f of g of 9. So I'm going to find g of 9 first. That's equal to the square root of 9 minus 4. Right, so that gives me the square root of 5. And it's not plus or minus because the square root was already there. So there's my g of 9. So then f of the square root of 5 is the next thing I need. That's equal to the square root of 5 squared plus 5 times square root of 5. So that gives me, square root of 5 squared is 5 plus, and then that's just going to be 5 square root of 5. That's all I can do. I can't combine them any farther, so this is f of g of 9. All right, g of f of 7. So that means g of f of 7. So I need f of 7 first. That's equal to 7 squared plus 5 times 7. So that is 49 plus 35. So I'll do 50 plus 35 and subtract 1, so that's 85 and makes it 84. So then g of 84 equals the square root of 84 minus 4, which is the square root of 80. Okay? So you simplify the square root of 80 on your own without a calculator. Pause this to make that happen. And then I will walk you through how to do it just in case you need it. If not, then you can fast forward through that part. But okay, so the square root of 80. So I can make a factor tree, right? My factor tree, I can say that this is 4 and 20. All right, well, 4 is a perfect square, so I'm going to stop there. 20 can become 4 and 5. 5 is a prime number. Well, even though these are perfect squares, I have 2 4s, so that tells me that since I have a pair, that g of f of 7 is equal to these 2 4s, or a regular 4, square root of 5. If you knew that 16 divided equally into 80, you could have gotten 16 times 5 in the first step, but it just depends on how you can think about numbers. All right, so now we're going to decompose a function. We're undoing it. We've put some together. We're going to go the opposite directions, okay? Now, look at the directions, okay? And the way directions are worded can really tell you some stuff about your answers. It says find 2 functions, f and g, such that this happens. So find 2 of them. It didn't say find the 2 functions. It says find 2 functions. So there are multiple options here, okay? So this f of g of x, and this is our h of x. So when it says f of g of x equals h of x, so this is the same thing as f of g of x equals h of x. Okay. That means we need to find f and g such that this would be true. So g, whatever it is, got substituted into f to make this happen. So there is more than one right answer. Okay? And we're going to talk about a couple of different ones on each one because you could think about it a few different ways. So I know I'm going to have an f of x and a g of x. Right? So if I know I'm taking g of x and substituting it into f of x, then I could start off by saying, well, this middle part here, that's my g of x because it's on the inside, so 1 minus 2x. If that's g of x, then f of x would have to be x cubed because I would take this, substitute it in for x, and I would end up with that. That's one option. Another option is maybe I didn't substitute this whole thing in. Maybe this is the part that I substituted in. So the g of x could be 2x. If that's true, then this part would have originally had to be x, so this would be 1 minus x cubed. And either set of those, if you do f of g of x, you will end up here. Okay, so you could look at it differently than your neighbor, and you both be right. So I'm going to do all 3 of the rest of them, but for each one, try to pause it and see if you can think of something, and maybe you've thought about, see if you can think of 2, and maybe you came up with both, or we came up with something different. We'll see. Okay, so I need an f of x and a g of x. So the inside part is g of x. So I'm going to make that x squared plus 1, which means this would be the cube root of x. So if I substitute this in for x, that's what I would end up with. Another set would be, maybe I didn't substitute in all of this, just this part. So let's say g of x is just x squared. If that's the case, then this would be the cube root of x plus 1. Okay? Either one of those things would work. Then let's look at, oh my goodness, sorry. Here. So let's say, okay, we need f of x, and we need a g of x. So let's just start with this part. What if g of x was x plus 7? If it was, then this would have to be 4 over x minus 1. But maybe this whole thing was g of x. So g of x might be 4 over x plus 7, which would mean f of x would have to be x minus 1. And on each one of them, just make sure, if you substitute that in for x right here, do you end up back with that? And the answer is yes, so we're going backwards. Okay, last one. If you haven't paused and tried any on your own yet, make sure you do that. So I need an f of x and a g of x. And I could say that this x plus 5 maybe was g of x, which means this would be negative 1/2 times the absolute value of x plus, sorry, just x. About to write the whole thing out again. Plus 3. Okay. Or maybe maybe g of x was the absolute value of x plus 5, which would mean f of x would be negative 1/2 x plus 3. Or maybe even, this way, I need an f of x and a g of x. So we'll do it this way too. Maybe g of x is negative 1/2 times the absolute value of x plus 5, and that would make f of x x plus 3. And I could even do it different with the signs, like I could still kind of come up with some more. So we don't know, but this is a set, this is a set, this is a set, and if I substitute it in, I should end up back there.